All right, so 7.1, we're talking about absolute value functions, which is something that you might be a little bit familiar with from previous classes. For some of you, this might be brand new. So we're going to look at the graph and what an absolute value function looks like. So over here on the left, it says begin by graphing the function f of x equals x, but it's got these two bars on the side of it. Now remember, those two bars mean that once you get one number on the inside, those two bars take that number and turn it positive. So if I had absolute value of -8, those two bars would turn it into +8. But if I had more than one number in there, like absolute value of -8 plus 2, I would do -8 plus 2 first and get -6. And then once I've got one number, that would change to +6. All right, so we got to be careful a little bit when you're doing some of this math that you remember to do the inside part first. But what it wants us to focus on today is not as much the algebra as the graphing. In fact, chapter 7 is all about graphing different types of functions. So when you first learned to graph, you learned to use a table. You pick a bunch of x values, you take those x values, you plug them into the function to get your y values, put them on the graph. So if I plug in -3, the absolute value of -3 is +3. The absolute value of -2 is +2. -1, absolute value is +1. The absolute value of 0 is 0. The absolute value of 1 is still 1. The absolute value of 2 is 2. Absolute value of 3 is 3. So if I plot these points, I'm going to start right here at the middle, 0, 0. And then I've got over 1, up 1. And then I've got -1 to the left, up 1. And then I've got over 2, up 2, over 3, up 3. I go to the left, -2, and up 2. I go to the left, -3, up 3. So the absolute value graph, when you connect these dots, you end up with a V. And that's what you're always going to end up with. Sometimes it's going to be shifted and moved around, skinny, fat, but you always end up with this V shape graph. Now, the one that we just drew is what we call the parent function. And all that means is that I have these absolute value bars and just a regular x on the inside. Nothing is happening to x, it's just x. What we can do is we can take x and we can manipulate it, okay? We can take this function, we can add numbers to x, we can subtract numbers from x, we can multiply numbers to the x value on the outside of the parenthesis. We can add and subtract numbers on the outside of the absolute value as well. And what that does is it changes the graph. It takes this V that we originally started with and it shifts it. Some manipulations will shift it to the right or up, down. Others will actually flip it upside down and change the shape of it completely. So depending on what we do algebraically to this function, it's going to, I better get that back to where we started. It's going to change what the graph looks like, all right? So you've got these notes that in this second box that says the standard form of absolute value functions, and it tells you what different types of numbers do to that graph, that regular looking V. So the first thing is if there is a number on the outside of the absolute value in front of it, that number is getting multiplied by the absolute value. We call that A. What that A does is it changes the slope of the V. So it's going to take your regular V and it can either make it really tall and skinny or it can make it a little bit flatter and wider. If that A is a negative number, it actually flips your V upside down and makes it look more like a mountain peak. So you've got some notes over here on the right talking about A. A positive A opens up, a negative A opens down, and A is the slope of the right half, and then it just gets copied going the other direction, right? So that's what this A in front does to our graph. Now, the h and the k, this h that's on the inside and this k that's on the outside, is what shifts our v. So that's what's going to move our v to the left, to the right, up and down, are those letters right there. So if you look at the notes over here on the right, it says the vertex of your v. Now the vertex is this point right here. It's where it's kind of the point of the v. We call that the vertex. So the vertex of our graph is at hk. And then if you look over here on the right, h is right here and k is right here. Now this can be a little bit confusing because h has a negative sign in front of it and k has a positive sign in front of it. The reason that the h has a negative sign is over here, we should maybe make a note. That letter h is going to move the function to the left and the right. The letter k is going to move the function up and down, but the letter h, the minus, means that it moves it in the opposite direction. So over here on your notes, I want you to draw an arrow to h, and I want you to write that it moves in the opposite direction. And what I mean by that is if a negative h moves to the right, a positive h moves to the left, which seems backwards, okay? But k doesn't do that. K moves the function up and down, but it doesn't do the opposite. If it's a positive k, it moves up. If it's a negative k, it moves down. So this is the one that can confuse you guys sometimes when you're graphing these, is to remember which one goes opposite and which one doesn't. So make a little note right there in your notes so that you can use that on the homework and going forward. So depending on what these letters are, it's going to change the shape of our graph. Now, there doesn't necessarily have to be a letter there. So for example, if there wasn't an H, then that just means my graph is not shifted to the left or the right. It stays right in the middle. If there was no K, if there was no number getting added on the outside of the absolute value function, then my graph is not shifted up or down at all. It's just on the normal x-axis. Now A, if there's not a number in front, then A is just 1, which means it has a normal slope. It goes up 1 over 1 in both directions. It's not getting squished, it's not getting stretched or anything like that. It's just the regular shaped V, all right? So first couple examples, it wants us to write the vertex, and then it wants us to state whether the graph opens up, down, and then it wants us to actually draw the graph. So when I look at example A, f of x equals, I've got a negative out in front. I've got this negative in front of the parenthesis, which tells me that my graph is going to open down. So it's going to look upside down instead of like a regular V. The fact that it's just a negative, that there's not a 2 or a 3 or a 4, means that my slope isn't going to change. It's just going to be upside down. So it's going to go, instead of up 1 over 1, it's going to go down 1 over 1. It's just flipped upside down, right? Now, the negative 2 and the 3 tell me that my function is going to be shifted to the right 2 and shifted up 3. So my vertex, instead of being at 0, 0, my vertex is over 1, 2 and up 3. So my vertex is going to be right there. And then to graph it, I just draw the rest of the graph. Now, it goes down. So I'm going to go down 1 over 1 and put a dot. And I'm going to go down 1 over 1 again, down 1 over 1, because my function opens upside down. And then I'm going to do the same thing to the left. I'm going to go down 1 over 1 to the left, down 1 over 1 to the left. And I can do this as many times as I want until I'm ready to connect the dots. But your graph is going to end up looking something like this. It's an upside down V that's shifted to the right 2 and up 3. Okay, example B. Out in front, I've got a number 2, which means my function is going to open up. So it's going to be a V, but my slope is going to change. My slope is going to be 2 instead of 1, which means when I'm drawing my function, I'm going to go up 2 over 1 instead of the other way around, or instead of just up 1 over 1. Then I've got this plus 1 and negative 4, which means that my vertex is negative 1, negative 4. Okay, remember the one on the inside goes the opposite direction. The one on the outside stays the same. So my vertex is down 1, or sorry, to the left 1, down 4. So my vertex is right here. My function opens up and it has a slope of 2. So I'm going to go up 2 over 1, put a dot, up 2 over 1, put a dot, up 2 over 1, up 2 over 1. And then I'm going to do the same thing to the left, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. I think that's plenty of dots there. Whoa, I missed that one bad. All right, straighten out for me, line. There we go. So my V's a little bit skinnier. That's what that 2 out in front did, is it made my V skinny because it changed the slope. It made it taller and skinnier. Now C is going to do the opposite. C, out in front, I've got a negative, which means I'm going to open down. But I also have a fraction for my slope. My slope is negative 1/2, which means instead of being taller and skinnier, it's going to be shorter and fatter, right? Because my slope is not going to be as steep. There is no number inside with X. So my function is not shifted left or right. So I put a 0 for my vertex, but it is shifted up 2. So my y value for my vertex is 2. So I go over 0, I go up 2. There's my vertex. Now my function is upside down, and it has a slope of negative 1 over 2. That means I go down 1 over 2, down 1 over 2, down 1 over 2. And I do that in both directions from my vertex. Down 1 over 2, down 1 over 2, down 1 over 2. So this one looks a lot flatter than the last one because my slope is a half and it's flipped upside down. Okay? Now, example D, instead of giving you the function, it gives you the graph and it wants you to write the function. So it wants you to write this equation, but plug in the right numbers for A, H, and K. So when I look at this, A is my slope of my function. And when I look at my function, it goes up 1 over 1, up 1 over 1. So A is just A is just 1, right? It's just a regular slope. So I could put a 1 in front of the absolute value, or I could just leave it blank. I'm going to leave it blank because I don't like to write numbers that I don't need. Then I've got an X, and now I've got to look at H. Now remember, H is my left and right shift. This function is shifted to the right over to the 3. But it's shifted to the right, so it's going to be minus 3 instead of plus 3. And then the K value is my up and down shift. Well, this function is shifted down to negative 1. So I would put a minus 1 on the outside of the absolute value graph. So my function is f of x equals absolute value x of minus 3, and then the minus 1 on the outside. Okay. Now the second example is upside down. So I know I'm going to have a negative in front of my absolute value. And then if I look at the slope, I'm going from this point and I'm looking for another nice point right here. So I go down 1 over 3. So this one's going to have a slope of negative 1/3. Then my absolute value bar. Now x goes first and then plus or minus h. In this case, my function is shifted to the left 2. So I'm going to put a plus 2 on the inside. And it's not shifted up and down at all. It's actually still on my x-axis. So I'm not going to put any numbers on, I don't have a k. I mean, technically it's plus 0, but again, I don't want to write unnecessary numbers. It's not shifted up and down at all. So that number's 0, so I'm just going to leave it blank. All right. Okay, time for you to practice these problems. Kind of a nice, easy start to the quarter, a basic function. We're going to take these ideas and apply them to more complicated functions later, but today we're starting with an easy one. Just be really careful as you're doing these problems to remember that inside shift is shifting it in the opposite direction. Don't make that mistake on the homework. All right, good luck.